Hi everyone, thank you for joining. So in this video we're going to solve another interesting integer equations that we're given that k, l, m and n are integers, and we're given this equality. We want to show or prove that this equation has infinitely many solutions, right? If you like to pause the video and try it yourself first, then we could go over it together. Right, well, one obvious solution would be, just by inspection, that if we say k is equal to m, and let n be a square number, such that l is equal to root n, let's take it the positive root only, right? So that will clearly solve this equation, right? You know, let k be 1, l be 2 squared, that would mean k is equal to m is 1, and n is l squared, so that's just equal to 4, right? So this will indeed give us infinitely many solutions, right? But these solutions are not very interesting, so let's have a look at more interesting solutions without having these conditions. Okay, so let's rearrange it. So we have k squared minus m squared plus l squared is equal to n. Let's use the difference of squares. We have k minus m times k plus m plus l squared is equal to n. Now, since we are interested in infinitely many solutions rather than all the possible solutions, we have the freedom to set this to be something easier to work with. So let k minus m be 1, right? This implies that k is equal to m plus 1. In other words, m is equal to k minus 1. So if we plug that in there, we have k plus k minus 1 plus l squared is equal to n. So we have 2k minus 1 plus l squared is equal to n. Now let's make k the subject. So we have 2k minus 1 plus l squared is equal to n. So that implies we have 2k is equal to 1 plus n minus l squared. So k is equal to 1 plus n minus l squared over 2. But we want this to be an integer, so we choose l such that l is equal to n plus q, where n and q are integers. But not only that, we choose q to be 2r plus 1. In other words, we want q to be an odd integer because it will ensure that k is an integer. Now to see this, let's plug it in. So we have k is equal to 1 plus n minus, instead of l squared, we plug in n plus q squared over 2. Instead of q, we plug in n plus 2r plus 1 squared over 2. If we expand and simplify that, we're going to have k is equal to 1 plus n minus n squared plus 2, 2r plus 1, n plus 2r plus 1 squared, close brackets. All divided by 2, so k is equal to 1 plus n minus n squared minus 4r n minus 2n minus 4r squared minus 4r minus 1, all divided by 2. So in other words, k is equal to, if we do the simplifications here, we have plus n minus 2n, so we will have minus n squared minus n. And if we divide this by 2, because the rest of the terms, as you can see, 1 here will cancel with that one. So the rest of the terms are divisible by 2. So we have minus 2rn minus 2r squared minus 2r. And we can write this as k is equal to minus n plus 1 over 2 minus 2rn minus 2r squared minus 2r. Well, this is clearly an integer. Since this is clearly an integer and we have two consecutive numbers, we'll always divide 2. And since we have m is equal to k minus 1, that implies m is also an integer. And we define l to be n plus q, so this is also clearly an integer, where q is an odd number, 2r plus 1. So this is k. This is m, this is l, and this is q, right? And the equation given was, we had k squared plus l squared is equal to n plus m squared. So let's choose some random value to see that this relation indeed holds. Let n be -1 and r be 1. K is equal to -2, -1, -2, -2, which gives us -2, right? Just plugging these values into that. Right? So Q is equal to 2r plus 1. Well, r is 1. That implies Q is equal to 3. L is equal to n plus q. That implies L is equal to 2. And finally, m is equal to k minus 1. That implies m is equal to -3. Okay, let's test the equation. K squared, which is -2 squared, plus L squared, which is 2 squared, is it equal to n, which is -1, plus m squared, which is -3 squared. Well, we have 8 is equal to 8, clearly. Let's choose another set of value for n and r. Let's say n is equal to 2 and r is equal to 3. Plug it into this, to the equation. So we have k is equal to -2, 3 over 2 minus 12 minus 18 minus 6. So that implies k is equal to -39. Well, q is equal to 2r plus 1 implies q is equal to 7. L is equal to n plus q, which implies L is equal to 9. And m is equal to k minus 1, so m is equal to -40. So let's test these values. We will have k squared plus L squared. Is it equal to n plus m squared? So n was 2, so 2 plus -40 squared, right? Okay, so -39 squared is the same as 39 squared, so let's write it as 40 minus 1 squared plus 81. Is it equal to 2 plus 40 squared? So we have 40 squared minus 2 times 40 plus 1 plus 81 equal to 2 plus 40 squared. So let's get rid of 40s. On the left hand side we have 82 minus 80, which is 2, which is equal to right hand side, so it works, right? I hope you found it interesting and I hope you found it challenging. Thank you very much for joining, and I look forward to seeing you in my future videos. Thank you.